It's a pleasure to welcome you all here. My name is Timo Kederer. I'm a professor here at the Institute of Computer Science and chair in the software engineering group. And as already mentioned, it's my pleasure to be the head of today's PhD defense committee of the PhD of your Niklaus. And you can already see the title on the slide. So it's on Decoding Legalese without borders, multilingual evaluation of language models on long legal texts. Yeah, so it's a hot topic. It's language models. And we will see what Joel did with them. And the work, the research was supervised by Matthias Stürmer, probably familiar to most of you, to all of you. So he's also leading a research group here at the Institute on digital sustainability, but he's also a professor and at the Institute, I think, at Fachhochschule, at BFH. And I'm also happy that external review could make it also physically to the defense, which is not that common anymore after COVID. So thanks a lot for being here.
Thanks for the invitation. It was not so difficult to come to Switzerland.
Was not that difficult?
No, it was not a difficult decision.
That's good. Yeah, so he's not as familiar as Matthias. The external reviewer was Nikos Salietras, and Nikos is a professor at the Department of Computer Science at the University of Sheffield. And he's an expert in natural language processing and machine learning. So natural language processing today is not like natural language processing as it used to be. There is no more classical computer linguistics, tactical and semantic analysis. You don't have to understand anything about languages, but you need to be a machine learner. Right. So Nikos is very well suited to serve as external reviewer, which he already did. So the good news is that the written part, this is already done. So the hard work has been done. And now comes the final part of this overall PhD program for you, which is the presentation. I'm very excited to see what you did. I think you are too, and so I will stop this introduction and give the word to you.
Great. Thanks so much for the introduction, Timo. Yeah, great to see so many familiar faces here. I would very much like to welcome you today to my PhD thesis defense on the dissertation Decoding Legalese without borders, multilingual evaluation of language models on long legal texts. Justice systems are horribly overwhelmed, and this all over the world. Be it in the United States, with courts being backlogged, especially in immigration, in the UK, with the family court system, even in France, in Germany, and also in Switzerland, especially in India, where it would take 300 years, according to some estimates, to clear the entire backlog. And in Brazil, where they now even turn to AI to help solve the large backlog. I'm sure you've all heard of LLMs, and they're amazing at many different things. Here is a short overview of from OpenAI, telling us some examples of what ChatGPT is good at. For example, grammar correction, parsing unstructured data into tables or JSON, calculating time complexity, so some like computer science tasks, and so on. But to give you an example of which I am particularly impressed by, is the coding abilities and the understanding abilities of ChatGPT in this example. So here I gave ChatGPT a CSV file containing the Gini coefficients of all the countries in the world where I think the World Bank has data for. So the Gini coefficient tells us about the income inequality of different countries. The higher it is, the worse the inequality. And I asked it to generate a plot for this. So that's the output of ChatGPT. We can see it followed the instructions. I asked it to delineate the x-axis in steps of 10 years and to show the Gini coefficient on the y-axis, and we can see the development for different countries over time. It gives a short summary here, and if we would click here, we would see the code that it has written and executed in a sandbox. So you saw some amazing capabilities of these models, but still they make many mistakes, especially in the legal domain. For example, some lawyers used ChatGPT earlier last year to help them write cases or like complaints. And what happened was ChatGPT hallucinated citations. And this, it turns out, surprisingly, that courts don't like that much if you cite cases that don't exist. So these lawyers, they got fined and fired from their law firms. So why is reasoning over legal text so difficult? First, legal text is very complicated. I'm sure you've all maybe tried to read terms of service documents and then probably given up. Yeah, you may have signed contracts. Yeah, you get the point. The legal language is even called legalese by some people. Second, it's very long, often containing thousands of words. Then third, you need legal knowledge to understand these documents. So you need to know like relevant legislation or case law, and sometimes even legal analysis. And finally, legal text is different in each jurisdiction. So it's not like computer science or medicine, which is universal worldwide, but depending on different laws or case law, a very similar fact pattern could be treated differently in different countries. Okay, so let's look at the outline of today's talk. First, now I just gave you a little overview of why legal NLP is important. Next, I will go into the need for multilingual datasets and models, a key part of our work. Then I will give you a quick overview of the publications in this PhD. Then I will go into a deep dive of 3 papers to give you a little bit of a more detailed impression of what we did. First, Lexstream, then the multilegal pile, and finally Scale. Finally, I will conclude with some conclusions and give an outline of future work. And this would not have been possible without many people, many of those present here today. And finally, we will have some time for questions. Okay, so let's go into the need for multilingual datasets and models. Here you can see the web interface from Hugging Face, a startup in the AI space that just recently reached a valuation of, I think, like $4.5 billion. And they aim to be the GitHub for AI. And that means they publish all kinds of data sets, models, and also some code, some demos online on their hub. And here I want to show you the amount of models available for the English language. So you can see there are almost 30,000 online freely available. If you look at Italian, the picture looks quite different already. We only have a little over 1,000. It looks very similar if we look at data sets. So for English, there are over 6,000 data sets at the time I took this screenshot. And for German, there is only like 500. Okay, so next, let's look into the publications that I did in the last 3.5 years. So this is a bit of a unwieldy list. So let me break it up into some topics that are a bit easier digestible. These are the main topics of the papers. I categorized them in a way that I saw made the most sense. So first, there is judgment prediction. Second, we will look at benchmarks. So how do we measure the performance of these models? Third, we have domain adaptation. So how can we make models that are general better suited for the legal domain? Then we looked at different supporting tasks. And finally, we looked at anonymization and the risk for re-identification. So for judgment prediction, we have these 4 papers, Swiss judgment prediction dataset in Switzerland. Then we looked at cross-domain and cross-lingual transfer. We also looked a little bit into explainability and fairness on judgment prediction in Switzerland. And finally, we also looked at the more realistic setup of judgment prediction from complaints and not from facts descriptions in the US. We created 3 benchmarks: Legal Bench for the US, then Scale, suited for the Swiss jurisdiction, and Lexstream for the EU. You see the little magnifying glasses there, and these signify that I will take a more closer look at those papers afterwards. In domain adaptation, we created the multilingual pile, a large data set of legal text for pre-training. And we created the budget longformer, which is a legal-oriented language model suited to process longer text. In the supporting task, we looked at sentence boundary detection. So where does one sentence start and the other end? We looked at negation scope resolution, and we looked at legal violation identification in legal events. Finally, we anonymized or helped the Supreme Court of Switzerland anonymize cases automatically. We also studied in anonymity at risk the risk of large language models re-identifying individuals from Swiss court decisions. And we also finally studied with public procurement documents how we could re-identify companies from Swiss court decisions. So here you can see the overview into the different topics of the 15 papers. I'll just take a quick sip. Okay, so now let's go into the deep dive. At this point, I would really like to thank all my amazing collaborators for the great work they did, without whom it would not have been possible. In alphabetic order, Elias Chalkidis, Andrea Galassi, Dan Ho, Meton Matoshi, Pooja Rani, Vishwaksenan Razia, Ronja Stern, and Matthias Sturm. Thank you very much. Okay, we will look at Lexstream, a multilingual and multitask benchmark for the legal domain. Next, the multilegal pile, 689 gigabyte multilingual legal corpus. And finally, Scale, scaling up the complexity for advanced language model evaluation. In the benchmark made by Stanford called HELM, Holistic Evaluation of Language Models, in the in the original version, they only had 3 tasks or 3 datasets that contained legal data: MMLU, LSAT, and legal support. In existing benchmarks we compiled for the Legstream paper, we see that there are only few benchmarks available for legal text, namely LexGlue and LBox, and they're monolingual. There are different benchmarks for different domains, but many of them are monolingual. So this is what we fix in Legstream. We make it a multilingual legal benchmark. So let's take a closer look at it right now. So why did we create it exactly? Most benchmarks are English only, and often they are for newspaper or Wikipedia data. So multilingual and domain-specific benchmarks are still rare. As you know, language models made huge progress over the recent years, and many benchmarks are saturated right now. And this is why we need more difficult benchmarks, and these difficult benchmarks are often domain-specific. So Legstream is a multilingual, multitask benchmark for a specific domain, namely the legal domain. Let me give you some statistics to give you a little bit of an idea. There are 11 data sets we selected out of 108 that we surveyed. And these that I'm showing you right now are the multilingual ones. We also have some monolingual ones that add to the diversity. Then on the right side, you can see some statistics around the size of the data sets with the number of examples in the training, validation, and test set, and the number of labels. So the ones that I'm highlighting right now, they have very large label sets, and this makes these tasks especially difficult. So how does one of these tasks, how do these tasks actually look like? So let me give you one example. Online terms of service documents. Here we have a sentence that the model needs to classify. So for example, this one, as such, the services may change from time to time at our discretion. And what the model has to do, it needs to classify first whether this is clearly fair, potentially unfair, or clearly unfair. And then it also has to decide the category it belongs to. So in this case, it's potentially unfair, and it belongs to the category unilateral change. Okay, so we have all these tasks. What models did we evaluate? We looked at 5 encoder-based multilingual models: MiniLM, DistillBERT, MDBERTA v3, and then 2 sizes of XLMR. You see on the very right that they are trained on at least 100 languages. Okay, so we evaluated those models, but now how do we aggregate results? We have 11 data sets and sometimes multiple configurations per data set, and then we have multiple languages per configuration. So it's not quite trivial. So how did we do this? This is challenging for, as I said, for multilingual and multitask benchmark. In our work, we wanted to promote fairness. So both across languages and across datasets. Because we focused on understanding tasks, we could use the F1 score everywhere, and this made it very easily comparable. We also used the macro averaged F1 score because many label sets are imbalanced, and with the macro averaged F1 score, we can equally weigh each of the label. The F1 score internally uses the harmonic mean, which gives more weight to smaller values, again, promoting robustness. And we did this in our aggregation strategy as well. So we created 2 aggregate scores. First on the data sets, where we aggregated over the languages in the tasks. and then over the tasks in the datasets. When we look at the results, we can see that XLMR large, the largest model, gets the best performance overall. This is pretty much to be expected and consistent with prior literature. But there are some exceptions, for example, Greek legal code and German argument mining, where some smaller models get the best performance. Then we aggregated over the languages, where we first aggregated over the tasks in the datasets and then over the datasets in the languages. So again, we can see the XLMR large model achieves the best performance. But here, the ordering is swapped. So MD-Berta achieves better results across languages than XLMR base. Interestingly, also native BERTs, which are monolingual models just suited for this one language that we evaluated them on, are the best in some languages like Czech and Greek. Maybe due to like special vocabulary or special scripts in Greek. In Czech, I'm not sure. Okay, so finally, we aggregated these two scores into a final extreme score to give a quick impression of how these models performed. And again, you can see the models behave as we would expect, that the larger the model delineated by the size of the circle, the better they are. Again, you can see MD-Berta base is better across languages, but XLMR base is better across datasets. So to conclude, we selected 11 out of 108 surveyed datasets to create the first multilingual legal benchmark. Then we established a point of reference with 5 multilingual models on LegStream. The entire dataset is available online on Hugging Face for any interested people to use and evaluate on. Okay, so let's look at the multilingual legal NLP progress bar. And we see now we have the multilingual legal benchmark. But you can maybe see it in Einstein's face that he's not perfectly happy yet, because he also would like multilingual legal models. And that's what we did in the next paper, Multilegal Pile. So why did we create it, the multilegal pile? As you may know, LLMs need huge amounts of pre-training data. But again, here, most corpora are English only, and here they're mostly predominantly based on web crawls. So again, high quality, multilingual, and domain-specific corpora are rare. And that's what the multilegal pile is, focused on the legal domain. So what is in the multilingual legal pile? First, there is the EURLEX resources, where we scrape the EURLEX database. This contains case law, decisions, recommendations, regulations, and so on from the EU. And those are often available in all 24 EU languages. Then we scraped some national case law and legislation ourselves from 14 EU languages. Third, we filtered a web crawl data set for legal data by using legal citations. And finally, we integrated the pile of law data set, which is from a colleague of mine and focuses on the US. So how does this data set look like in terms of different text types? As you can see here, more than half of it is case law, mainly US case law. But then there is also the diverse internet documents in legal MC4. there is some legislation, some contracts, and some other documents we didn't group into those four. Here you can see the distribution across languages. And you may be surprised that English is still the largest language, even though we claim that it's a multilingual corpus. But in comparison to many or most other corpora, this graph would look very different. It would, like, English would be 90% or more in many corpora. And here we have many other languages that have a very large percentage of the total corpus. So by extending our data set from English to all the 24 EU languages, we cover 2 times more total speakers. We go from 1.5 billion speakers to 3 billion, and we cover 4 times more native speakers, 1.5 billion instead of just 380 million. Okay, so we then use this corpus to train these multilingual legal models. We train different variants, we train different sizes, some multilingual ones, some monolingual ones. Yeah, we reduced the vocabulary a little bit because we got rid of many languages to make it a bit more efficient. Then we evaluated those models on the LegStream benchmark, finding that the small or the base size legal model outperforms even the large general purpose model. But the large one is on par with the base size model for unknown reasons. The best scores are achieved by the long-former model, capable of handling up to 4,000 tokens, approximately 3,000 words, instead of just 500 tokens as done by most other models. We see that in single label text classification tasks such as Brazilian court decisions, German argument mining, Greek legal code, and Swiss judgment prediction, the long-form model is performs especially well. For named entity recognition tasks, maybe these tasks are already a bit more saturated, and we don't see any performance improvements. When we look at the LegStream results aggregated over the languages, we see that our legal models don't improve over the general baseline. And the long-form model is even a bit worse than the base size models, surprisingly. Interestingly, the monolingual legal models perform very well there, especially in Croatian, in Latvian, Maltese, Dutch, and Slovenian. They even get the best scores across for these specific languages. So it might be worth training just a monolingual model for some languages. We also evaluated on LexGlu, an English benchmark for the legal domain, and we found that our English models get the new state of the art, the large one, with getting the best scores for European Court to Human Rights, American Supreme Court, and EURLEX classification, and for case hold as well. Again, we see for LETGAR and unfair terms of service, these tasks may be a bit more saturated, and domain adaptation does not seem to help a lot. To conclude, we created a 689 gigabyte multilingual legal corpus. We pre-trained 2 multilingual, a long-former, and 24 monolingual models, and set the new state of the art on LegStream and LexGlu. Again, the dataset is available on Hugging Face, as are the models as well. If you look at Einstein this time, he's already a bit more happy, because now he also has the multilingual legal models. But he's still not perfectly happy, because now he would also like an end-to-end modeling of the judicial system. And you guessed it, this is what we tried next. We did scale. So why did we create this? Scale attempts to be the first end-to-end benchmark for a judicial system, covering 650,000 cases and 35,000 laws. It contains tasks like court view generation and long document-to-document retrieval, which are very scarce. As well, multilingual corpora from the same jurisdiction are very, very rare. So scale includes very hard tasks multilingually from the same jurisdiction. So let's look a bit at what is in there. First, we have law area prediction. We see this as a continuation and as really an end-to-end modeling, or as a suggestion for how NLP could be used to model and help in the judicial system from the beginning to the end. We start with law area prediction, which aims to help routing cases or incoming complaints to the correct department or chamber. Then criticality prediction, where we try to prioritize cases that are maybe harder to solve and give them to the more experienced judges, or to the more senior people, and the easier cases could maybe in a futuristic world be attempted first by an automated solution. Then we have information retrieval and citation extraction, which can help the lawyers get access to relevant information. With the court view generation task, we aim to help the clerks and judges draft decisions. With the judgment prediction, we could verify based on the history of a certain court whether a certain prediction or a certain judgment made is consistent with the history. With criticality prediction, again, we could classify the most important cases. For example, at the Supreme Court level, there are some cases especially published as separate volumes, and this could be maybe supported. And finally, we had the task of leading decision summarization, where we summarized cases into shorter, more understandable summaries. Overall, we have the pre-training corpus that helps inform the language models trained to do all these tasks better. So what makes scale special? Again, we have very long documents, up to 50,000 tokens. It uses domain-specific knowledge embodied in the legal texts. It needs multilingual understanding, covering 5 languages. And it's a multitask benchmark, again, in 4 task categories. So let's look at some tasks in a little bit of more detail, starting with the prioritization task. So some people say, or it's a legal saying, justice delayed is justice denied. So in overworked or overwhelmed judicial systems, it may be beneficial to prioritize, to like in the medical system, to triage basically. So that's the goal of this task: prioritize important cases and route them differently, maybe. As inputs, we take the facts of a federal case. This is a proxy because we don't have access to the complaints, the actual documents that we would like to study. But yeah, since we don't have access to these documents, we took the facts as a most close type of text. Then as output, we predict the criticality or the importance of a certain decision. Next, let's look at information retrieval. This is basically the central point of systems like Thomson Reuters Westlaw or LexisNexis, which aim to provide lawyers with relevant citations and relevant texts. So we aim to aid lawyers in legal research. As input, again, we have the facts of a case. And as output, we want to predict relevant case law and legislation. Next, let's look at the court view generation task. So here we aim to aid clerks in drafting decisions. And we do this by giving the model, in the ideal case, as input both the facts, or not only the facts, but also relevant legislation and case law that we may have retrieved with the information retrieval task before. And if it's at a higher level of appeal, also the lower court decision. As output, we just generate the legal reasoning. Here I want to note that the court view generation task is very hard. The average age of appointment at the Swiss Supreme Court is 50 years. So this is not a task that anyone could just solve. The relevant legislation, case law, and analysis are multilingual in Switzerland. And the input size can be enormous. So if we take all of this information, it can be well over 100,000 tokens. So that's a big book. Also, the output size can be very large, with an average of 4,500, but up to 50,000 tokens. This is a very large challenge for current models, and yeah, not really solved yet. Finally, let's look at leading decision summarization. This is what the output would look like, the so-called regeste. And you can see, yeah, the goal of this is making case law more accessible, both for lawyers and maybe also for laypersons. As input, we have the full text of a leading decision. And as output, we produce this summary. And this summary consists of 3 parts. First, important citations, denoted in orange. Next, keywords from a thesaurus in blue. And then finally, some free text, which is the main theme of the summary. Also note that in here, there is some reference to a specific number of a consideration in the main decision. To conclude, we created a multilingual benchmark from the same jurisdiction with 8 classification tasks, 2 generation tasks, 1 information retrieval task, and 1 token classification task. Models we tested, even our in-domain pre-trained ones, they still struggle greatly in many tasks, especially in generation and in information retrieval. Again, we make the entire benchmark available publicly on Hugging Face. And finally, Einstein is happy. He has his multilingual legal benchmark. There are multilingual legal models, and we can also model a judicial system end-to-end. So this begs the question, are we done? And as you would have guessed, we're still in science here, or try to be. And the science is never done. But let me finish with some conclusions and then give you a little outlook of future work. So these conclusions are over the entire thesis. I may not have covered everything here, but just to give you a little bit of an idea of what I thought was most important for the entire dissertation. So we created many data sets. We created unlabeled large document collections for self-supervised pre-training. We looked then into lower level structural tasks like sentence boundary detection, negation scope resolution, and citation extraction. These would be the ones I would call supporting tasks from the categorization before. Then we looked at more complicated classification tasks, such as law area prediction, judgment prediction, criticality prediction, or court decision re-identification. Fourth, we looked at information retrieval for legal research. And finally, we also looked at complicated free-form generation problems, such as court view generation or leading decision summarization. We make everything available on Hugging Face, such as the multilingual pile and on the RCDS page as well. Next, we looked into model training. So I pre-trained a host of multilingual and monolingual language models in 24 languages. I fine-tuned models for the tasks above or in the slide before. And they're all also available online. Finally, we looked at creating benchmarks. So selecting and aggregating suitable data sets for a more holistic and comprehensive evaluation of LLMs in the legal domain. So not only evaluating on one data set, but evaluating on multiple data sets at the same time. We released openly our benchmarking code on GitHub for people to use. And we integrated it into the Stanford Helm benchmark. Again, here are the links for anyone interested. So now let's look at some future work. Obviously, we could try to continue pushing the state of the art on legal benchmarks. Some avenues I would pursue if I were to do this were domain adaptation. So we could do large-scale continued pre-training, for example, on the multilingual pile, also for large generative models and not only for smaller encoder-based models. We could look into large-scale instruction fine-tuning. For that, we would need to curate a legal instruction tuning dataset. We could look into sophisticated prompting techniques for legal reasoning. An existing, more sophisticated prompting technique would be tree of thoughts. This could be tried out or other new methods developed. Another part of future work would be further analysis of these resources. For example, an overlap analysis of the multilingual pile. Here I would measure the overlap with pre-training data sets, such as MC4, to evaluate the real additional value. So how much is the same and how much is new. Then we could look more into explainability and interpretability of models. For example, could conduct a detailed analysis of model rationales for decisions. And we could expand on our error analysis. For example, we could do studies together with lawyers to make them more comprehensive. Also, if we know current failure modes of current models better, this could guide us, could guide further research for improving those models. Obviously, we could also further extend the data sets, for example, to cover more legal tasks. So maybe, again, work together with more lawyers, also in the private sector, to be informed what exact tasks they would do and try to create data sets for them. So far, we mostly focused on the public sector for that. We could also enhance the global coverage. So not only the 24 EU languages, but could go more broad to more languages and legal systems. And we could focus even more on data quality. So far, we used semi-automated dataset creation methods or annotation methods. These create very large label sets, but maybe the quality is not the best. So by working together with legal professionals, obviously making it more expensive, but maybe more high quality, that would be another avenue. So this is the end of my main talk. And now I would like to thank many people. First, you, the audience, for being here. and for your interest. Then to Mara Heusler for her unwavering law, support and understanding. To my friends and family for their encouragement, understanding and reassurance. To Michele Alberti for his invaluable advice at crucial stages. To Matthias Stürmer for his invaluable guidance and mentorship. To Elias Chalkidis for his persistent mentorship, practical advice, and steadfast support. To Dan Ho and Paolo Favaro for their advice. To Nikos Aletras for serving as my external examiner. I would also like to thank to the Swiss National Science Foundation for funding the project, and to Google TPU Research Cloud for providing compute for pre-training the models. And especially also to the NFP 77 project team, Andreas Lienhardt, Daniel Kettiger, Thomas Mürach, Magda Choduk, Nathalie Schwager, Tanja Munz, and Leonie Grob. And to my great students, some of whom are here today as well, and some taking pictures, I see. Nina Baumgartner, Tobias Brucker, Marco Buchholz, Ramona Christen, Roman Martinez, Alex Niffenecker, Vishwaksenan Razia, Alex Schürmann, and Ronja Stern for their unwavering commitment and invaluable contributions to this research. And I'm sorry, I won't read all of these amazing collaborators here, but thanks for the great collaborations. And also thanks to some groups, the University of Zurich Computational Linguistics Reading Group, Thomson Reuters Lab, Stanford Reg Lab, Stanford NLP Group, and Google X for great conversations during the research. Thanks, everyone, and I'm looking forward to any questions.
Yeah, thanks a lot for the talk. Well, so you guessed it right. Now it's time for questions and also answers. So we would start, of course, with our external reviewer with the question round, and I will hand over to Matthias as the supervisor. Maybe I have also some questions. Then we go for a second round. Typically, this is much shorter. It's only for handling those things that came up during the discussions. I will open up also the Q&A session for the audience, and then you have finally done, right? And here we go ahead.
Thanks. Yeah. Joe, thanks for this great presentation. Really enjoyed your talk, but also enjoyed reading your thesis. And by reading your thesis, actually realized how many papers you published. You've been reading the last 3.5 years. I think you made significant contributions to the field, and giving models and data sets to the community is really important. If you have to choose only one of the contributions you made, which one is you think is more important? Or actually, what is your most favorite paper from your thesis?
Thanks a lot, Niklaus. This is a difficult question. I like all the three that I presented in more detail today, but I think scale is probably at closest to my heart here. Yeah, because it is not only understanding tasks; it's also very, very challenging tasks that we cannot solve yet. The generation information retrieval, where we saw very weak performance of current models. And I also like and find it very interesting to see how we can support the traditional system from the beginning to the end in a very coherent way, or that's at least what we try to do there.
Yeah, thanks. I think that I really like the scale you have too. I like the big file as well. I thought you might choose this one, but can I ask one more question?
You can ask as many questions as you want.
So if you go back to, that's going to be a bit more technical. If you go back to the legal file results, you had a couple of tasks that your best models didn't really perform well. It was like from 3% to 20%. I don't remember. It was like a couple of tasks. Yeah, I think this is the one. So can you tell me what's, I don't remember, it's like C19 and me.
Yeah, COVID-19 emergency measures and the multi-year like tasks. So
Do you
these
have
are
any ideas why the results are very low? Or
yeah, this is a great question. So so we're talking about these two tasks here, right?
Yeah.
Yeah, so I mean they're here in C19 they're actually like the large model is actually the best one. These are multi-label tasks, and multi-URLX is for all 24 languages, and there we saw lots of variability. This combines 3 tasks. So on the first level, second level, and third level, so with varying label set sizes, especially the third level is very challenging. Yeah, so there I think there is also lots of how do you say potential for improvement, and we don't really know why exactly our models are worse than XLMR large in this task. They're still better than most other models. We also saw lots of variability across like different hyperparameters. We didn't really put effort into optimizing those because already running the benchmark like this was very compute intensive. But yeah, it's still deep learning, unfortunately. So like if we tuned the hyperparameters more, we would probably get quite different results.
Are you averaging across languages here as well? So the 42.2 is across all the languages, right?
Yes.
You see like any you have it in the previous slide, right?
Yeah, I think that I don't have the results for just multi-URLX on all the different languages, so I will need to dig that up. But here we can see the results over the languages, but for the different tasks. So here the other tasks are also calculated within.
Okay, yeah, thanks. It's good to have tasks.
Sorry?
It's good to have hard tasks in the data.
Yes. Yeah.
Okay, yeah, studying this.
Thanks. Yes, so also great thank you from my side. I'm very proud to have you as my first academic son. Therefore, I remember when we started almost 4 years ago, it was in the middle of the pandemic and it was quite challenging. So it was really amazing that you came up with these 15 papers now. For me, these 3 papers you presented are great examples of your work. It's difficult actually to choose because there are other publications which are also great. Maybe one which is very close to our original research project, the NRP project on open justice versus privacy. There we wanted to figure out, like, is it possible to de-anonymize court decisions with artificial intelligence? And so there was one paper co-authored or main author, which is about anonymity at risk. And maybe can you briefly just say, is it possible to break anonymity with natural language processing today, or what is the risk?
Thanks for the question. Yeah, we just discussed this yesterday, actually. The exact wording of this and how to phrase it correctly and in a balanced tone. So we studied 3 data sets. We studied re-identification on Wikipedia, where we just masked out, or Alex did the main work on this. We masked out the people, and there the models were quite good. but most models are trained on Wikipedia, or probably all models, so they know it. If we paraphrased the sentences, the performance dropped a little bit, but still it was quite high, around 40% or something, if I remember that correctly. Then we looked at court decisions, where the people are masked out by default because they're anonymized, and we tried to re-identify them. And the Supreme Court, how do you say, was so friendly to provide us with an aggregate statistic of the results there. But I think only one was partially correct, if I remember correctly. Yeah. So for court decisions where we don't know anything, it's very hard. So yeah, pretty much there's not really a tangible risk currently by just using large language models out of the box to re-identify based on their knowledge encoded in the weights. Then we did a third study where Alex manually re-identified decisions with newspaper articles. So we knew the ground truth, and there we with ChatGPT-4, it got 5 out of 7 correct, if I remember that correctly. So when we know that the result, when we know it is possible to re-identify, then yeah, it is possible, and the scores are quite good. Also, we need to note that we put the newspaper articles into the context. So first we retrieved relevant articles and put them into the context together with the decision, and then it was able to re-identify. So yeah, but it's very hard to estimate how the real risk looks like there, because we looked at 7 of the most easily re-identifiable decisions, and we expect that more decisions or other decisions will be quite a bit harder to re-identify, even manually. Does that answer the question?
Thank you very much. So this also goes with our again, one of our lawyers in the team. And maybe a second question about another paper you couldn't present in detail, but I think it's also quite an accomplishment, because it actually is now, as far as I know, in production at the federal court. It's about this language model you produced, and you actually tested it with the federal court, Daniel Brunner and Robin Mamier. So in this sense, what do you think? How much did it improve anonymization? Can you maybe briefly summarize the key points of this research project?
Sure, happy to. So what we did there was we did domain adaptation of these language models to the legal domain, basically very similar to what we did in the multilingual pile here. So, and I think I'm not sure which one is the one that produced the best results for the Supreme Court, but we not only trained the multilingual ones on 24 EU languages, but we also trained them on just the Swiss languages for a comparison. And I think, if I remember correctly, this one was the one that performed best. Yeah, we also compared them to just training on one language, but then it would be a bit more complicated in the anonymization system, because you would need to route to a different model for the different languages. And yeah, I don't remember the exact numbers, but I remember some recall being raised by 5 or 10 points by swapping out the general purpose model with the Swiss, or the model pre-trained on the Swiss legal data.
That's great. So really contribution to production, AI in production use of the Swiss government. That's all.
Thank you, Matthias. Yeah, so I have a couple of questions actually. So first of all, thanks a lot for this nice metaphor of making Einstein happy in 3 steps. If you remember history, making Einstein happy does not necessarily mean that you make all the researchers happy. Now, I was wondering about the rationale of having a multilingual setting in the first place. I'm not from the law domain, but if I think of certain countries, why should they be interested in having a multilingual solution at all? If I compare this to, like, for example, software engineering, we call it multilingual, corresponds to the one-size-fits-all approach, which we learned over the years does not work well. There are people here in this room who can tell more stories about this. So what was the hypothesis or the intuition that was driving kind of this research for coming up with such a multilingual setting, both on the benchmark side and on the model side?
Thanks. So basically, first on the benchmark side, as I showed in the beginning, most benchmarks datasets are available in English only, and there is a considerable barrier for language technology being developed for other languages than English, and creating those resources is very important, in my opinion, to remove or make this barrier smaller. Regarding the multilinguality on the model side, there is this concept called cross-lingual transfer, which basically says if you have some information in some language and you train on that, and then you evaluate on another language, the model learns something from this other language. And we could actually show this in one of our papers where we trained on an Indian judgment prediction dataset in English. We translated it to German, French, and Italian. We trained on those translations as well. And then the performance on the Swiss judgment prediction benchmark was actually increased. So, and also if you look at the results here, across languages, we see that some monolingual models are good in some languages, but overall in most languages, the multilingual models dominate. So there seems to be some transfer happening even to languages that are different.
Speaking about these monolingual models, do you know about the language similarity graph? I don't know if this is a scientific concept. It was just like back in my time when I was in Milano, we were a really heterogeneous group, and I was sharing my office with a woman from Greece, and we were always joking about him. Because if you build a language similarity graph, which is just a graph where an edge between two nodes represent languages, edges represent the similarity across these languages. And if you apply clustering algorithms, then it always happens that there are big clusters, right? Like the Roman languages and the German languages and so on. So this pattern is very similar to it. Right? That there was always one outlier, which was Greek. That was always standing alone because the similarity, it has not really similarities to many other languages. And maybe there is kind of a correlation, or even there's a causal relationship between this, how similar are these languages and how well performed, or is this transfer possible? Because you told me, at some slide you said that a monolingual model was performing very well for the Greek language. That reminded me just this language similarity. That was not a question, actually. It was more like a story.
Yeah, yeah. No, it's a very interesting. It's a very interesting story. If you remember, do you remember how the similarity graph was constructed? Like since Greek,
it was based on scientific method. Okay. But you can Google this and you'll find it.
Yeah. Yeah, maybe a short comment. Like I think like Latin is to some parts derived from Greek, or like has very similar grammar, or
it's, let's say, different branches of the European. They are very similar. Very similar. They're many concepts are very similar in vocabulary.
But obviously nowadays they have different scripts.
They have different scripts from the beginning.
Okay. Yeah. So Yeah, I wonder if this is like a reason why Greek was so different in the similarity graph that you were mentioning. And maybe, yeah, this is maybe also an explanation of why the monolingual model performs better here, because it can allocate its entire vocabulary to just the Greek script, whereas otherwise it needs to share it with the Latin script and
So you have some
Cyrillic.
hypothesis for explanation.
Yeah, that would be my hypothesis for the Greek, how do you say, underperformance of the multilingual model series.
Another question now, we see a lot of numbers here that clearly are kind of objective measures for assessing the performance of these models. What does this mean from a domain perspective? Okay, well, 50% accuracy are acceptable, the other 50% will be prison, but if it's not too long, then fine for me. Or so what does this mean? Like, is this something that is usable in practice? Is this used in practice? I have no idea.
Yes, this it's a great question, and this is one of the major limitations, in my opinion, of current research in legal NLP in general. Like many tasks are somewhat artificial, especially the judgment prediction task, since it is based on in many data sets it's based on the facts description, which are written after the decision is made, as I've been informed. So yeah, ideally we would want to predict, based on the complaints that are submitted to the court, what the judgment would be. And we did this in the US with class action cases, and the performance is much lower than when we use the facts as input. So the performance drops from like the 70s to the 50s. So like just a little bit over chance. So yeah, this is a current limitation of many benchmarks. My colleague Neil, he tried to mitigate this limitation by collecting, or by working together with many qualified lawyers to create the legal benchmark, where he really tried to make them more realistic and less something that a computer scientist would think of, but actually something that would be useful for a lawyer. And I think we definitely need more of these works in the field. Unfortunately, often we're constrained by having enough access or resources to talk to lawyers and to do large scale annotations with them, and that's why we resort to these semi-automated methods of doing data annotation, which is obviously not perfect, but like a large part of the status quo in this area right now.
And my last question is a little bit about related work. So you motivated your work by having a look at the really closely related works, in the sense that there are some gaps, right, regarding these benchmarks and the multilingual setting and so on. Some of the tasks that you showed, particularly in the third part of this end-to-end support, seem to be similar, very similar to tasks we have in related domains like medicine. Right? So medical research is a lot about text mining since many years, information retrieval, getting some useful information from a flood of publications. Now did you have a look into that? Into related domains outside the law domain?
We looked at some benchmarks, yeah. I think also in anonymization, for example, most of the work so far has been done in the medical field. What else did we look at?
So since you looked at the medical field, I was wondering about the performance of your results. Is this comparable to what they have in medicine, or are you way behind them? Is it really the case? Because the initial motivation is that also was that these texts, legal texts, are different, and intuitively I can agree. And you read a sentence and you do it 10 times, and then afterwards, yeah, okay, now I've got it, what they mean. But this could be some confirmation that this is really the case. So to compare this with the performance of like solutions for similar tasks in the medicine domain.
Yeah, for example, domain adaptation. So adapting language models to a specific domain is also being done for many different domains: finance, science, medical domain. I think in the medical domain, the gains are a bit larger. My hypothesis is that if you train your own tokenizer, then it gives you more gains in the medical field, because there are many tokens that are not present in standard language, but in the legal field that's not the case as much. In the legal field, the sentences are complicated, the sentences are long, but the words are pretty much the same as far as I understand this. There are some special words, or words have a little bit of a different meaning than they would have in regular language. But there are not as many like Latin words like in the medical field. So having a specific tokenizer adapted to your fields does not bring you as many gains. And I think that's like one reason that why in the medical field we would expect a little bit more gains. If that answers your question.
No questions anymore from my side. Asking for a second round among the experts. Are you happy already, or is something came to your mind?
Yeah, I mean, I would like to ask a little bit about your future work. I like these ideas of adapting, using the legal file to adapt decoder-only models, such as get a llama or multilingual group and adapt it to the legal file. I think that's a great idea. I think we should do that. Definitely. But how about this kind of like how do you see how we could adapt this? Let's say we had a legal llama, for example. What do we need in order to adapt it using preferences like reference optimization or human feedback, reinforcement learning, in order to make it generate text that actually might appeal to lawyers or judges or different stakeholders that might be using these systems? Do you have any ideas?
Yeah, I think that would also be an interesting avenue for sure. Like not only looking into instruction tuning after the pre-training, but also looking into preferences. Like for example, generating different legal reasoning and then letting judges or lawyers rate them, which ones they like better, which ones make more sense, which ones are more convincing. We also thought recently, I think it was in the reading group in Zurich, about something like this, where you could actually test it out then in real time by generating multiple reasoning description, multiple texts, and then letting a judge decide like how he would have ruled given a certain complaint. So like that, you get a very realistic signal of which generated reasoning is actually more convincing and better. And then you could fine tune the model with RLHF for that task, for example. So yeah, definitely a very interesting avenue as well, I think.
Thanks.
Well, it's okay. I have lots of more questions, but I think for time reasons,
As a supervisor, usually you should have asked your questions earlier. I have also more questions, so I would open the Q&A session also to the audience. There are questions for the audience.
You started your talk with the example of hallucination, the problem of hallucination. So in my own experience using ChatGPT, if I know the answer and I can check it, it's fine. Like if it's just rewriting text. But if it's something that I don't know the answer to, then the chances are very high that what's generated is nonsense. It's my experience. The tasks that you described, some of them are pretty complex and it looked like it would be really hard to manually check them. So my question is, how would you mitigate the hallucination problem in the legal domain? How do you, when you trust the results, do you have to have an army of lawyers to check the answers?
This is a great question, and I think currently it's an open research question in the LLM research in general, and many people are working on this. Something you could do that's very easy to do is you just ask the LLM basically, is this correct or not? But then the lawyers also asked ChatGPT if the cases that were generated were correct, and ChatGPT was like, "Sure, bro, they're all correct," and then they were hallucinated. So yeah, that also has its problems. Then you would go like generator and then a verifier, and then you would maybe generate again and verify again, and then when do you end the loop? Yeah, this is like one approach. You could obviously go to humans and then create more high quality data sets and train on them. And I think that's what most of the companies are doing right now. There are also these like special decoding or prompting methods like tree of thought that do multiple generations, let the model think during the generation by giving it more time to decode, to generate the text, and then hopefully it gets you a better answer. And we see some evidence on mathematical reasoning on the grade school level that these prompting techniques or these decoding techniques lead to quite large gains. But yeah, like hallucination remains an open problem, and there's no solution so far, as far as I know.
Thanks, Oscar. More questions? Not the case, and I will also close the Q&A session.
Sorry, maybe there is an online question. I don't know. There is not?
Online, but
No?
No.
I see a QA.
I
I
have
see a
to
one.
take the-
Okay.
But yes.
Okay. I just see a one in my QA. QA there. You don't see anything?
I don't have anything.
Okay, maybe only I can see. Let's check. Yeah, there is a question from Vinay. If you could run experiments where you incorporate additional non-legal data into the training of these legal models with the goal of improving legal reasoning, what data would you additionally train on? That's an interesting question. What non-legal data would I train on? Yeah, I think there has been some research showing that code, like training on code, improves reasoning capabilities. So yeah, that's probably what I would do. Otherwise, yeah, maybe like other kinds of reasoning, like domains where reasoning is important, could be another avenue. Like for example, these math problems. But yeah, obviously it's focused towards math. So yeah, I guess other domains with reasoning, especially code, if that answers it.
Studying more source code is a perfect answer. More No, we were already done with the audience. Are there more online questions? One more is permitted. No?
I think it's fine.
Then, thanks a lot again, Joel, for giving us this very nice insight into your research over the last years. Thanks again to the external reviewer, to the supervisor, of course, and to all collaborators who contributed to this nice research results. So what happens now is that the committee will leave the room for not a long time, but we will exchange our impressions as long as our minds are fresh. And as long as the impressions are fresh, and then we will come back. You're kindly invited to wait here. As I said, usually this doesn't take a long time, and announce parts of the results for this this oral exam, if you want so, the defense. Yeah, that's basically it. So you have done everything. Now we have to do something, and we will be back shortly.
Thank you. Thanks a lot for coming to the people online. I hope you enjoyed. I hope it was interesting, and yeah, hope to see you soon in person. Bye.